This video is the answer key for the sample test for Chapter 8. Upon completion of watching the video and correcting your answers on the sample test, you will need to go on to Study Island and take the assigned assessment for Chapter 8. So for number 1, we are simply filling out a table of values. So what you need to remember is that you're plugging in the x values into the function where you see the x. So for 1, we get y equals negative 2 times 1 plus 4. Negative 2 times 1 is negative 2. Negative 2 plus 4 is 2. So your first ordered pair is 1, 2. Remember that it's the x and the y. For the second line, we aren't given the x value, but if you look at the function, you can see that the negative 2 is what was plugged in, so the negative 2 must be the x. Negative 2 times negative 2 is 4. 4 plus 4 is 8. So your second ordered pair is negative 2, 8. Your last ordered pair is given, the x and the y, so you can see the x that gets plugged in is a 0. So we fill that out, and the output is a 4. For the second table, we have a little bit different function here. Y equals x over 4 plus 3. So we're plugging in an 8. 8 over 4 plus 3. Remember, that's like a division problem. You do division before addition, so 8 divided by 4 is 2. 2 plus 3 is 5. So for the first ordered pair, we get 8, 5. Second line, the function is given here with the 12 plugged in for x, so that's your input. 12 divided by 4 is 3, and 3 plus 3 is 6. So we get 12, 6 for our second ordered pair. The third ordered pair, you can see that 0 and 3 are the input and the output, so we're plugging in a 0. 0 divided by 4 is 0. When we add 3 to 0, we get 3, so you can see that that's correct. Now for number 3, it's the same idea. We're making a table of values in order to graph the equation. You don't have to make it as fancy as number 1 and number 2 above. You can just do an x and a y. Remember though, you always want to pick x and y values that are simple. So you could do something like 0, 1, and 2, 1, 2, and 3, negative 1, 0, and 1, whatever it is for you that's easiest. Remember too that the bigger the number gets, the more likely you are to get off the graph, and our graph only goes to 8 positive and 8 negative. So I'm going to use 0, 1, and 2, and I'm just going to do some mental math here. If I plug in a 0 for x, 3 times 0 is 0, 0 minus 2 is negative 2. Plug in a 1, 3 times 1 is 3, 3 times 1 is 3, minus 2 is 1. And finally, 3 times 2 is 6, 6 minus 2 is 4. So I have 3 ordered pairs, 0, negative 2, 1, 1, and 2, 4. And then what you're hoping is that you make a straight line here. If your dots aren't in a straight line, you need to be double checking your math, because we are only dealing with linear equations. 4 and 5, you're using the slope formula. I like to label these first, x1, y1, and x2, y2. So for the top, we have y2 minus y1, so that's 4 minus 6 over x2 minus x1 is 2 minus 3. And you really need to watch your signs here. 4 minus 6 is negative 2. 2 minus 3 is negative 1, and when you have a negative divided by a negative, remember that is a positive. So negative 2 divided by negative 1, our slope is 2, or you could write 2 over 1. For number 5, again I'm going to label x1, y1, x2, y2. So it's negative 2 minus 4 on top if you follow the formula here. And on the bottom it's 5 minus negative 7. I'm going to put that in parentheses. You need to remember here to add the opposite. You are able to use a calculator, but negative 2 minus 4 is negative 6. 5 plus 7 is 12, and that reduces to a negative 1/2. So the slope on number 5 is negative 1/2. Moving on to page 2, you're just asked to find the slope of the line from the graph. So this is simply where you're counting the rise over the run. So I'm going to start here at this first ordered pair, and I'm going to go up 2 and over 1, 2, 3, 4, 5. So I went up 2 and over 5. It's the positive direction. This slope has, or this line has positive slope, so my answer is 2/5. Remember, it's the rise up and down first over the run. The rise number goes on top and the run number goes on the bottom. For number 7, again, I'm going to start down here. I'm going to go up 1, 2, 3, 4, 5. So up 5 and over 1, 2, 3, 4, 5. So up 5 over 5. 5 over 5 reduces to 1. What you do have to recognize here, though, is that this line has negative slope. So your answer here is -1. 8, 9, 10, and 11, as I walked around the room, it seemed like most of you understood this. A positive slope goes in this direction. Negative slope would then go in the opposite direction. 0 slope is any horizontal line, and undefined slope is any vertical line. For the next set of examples, I'm just asking you to state the slope and the y-intercept of each equation. Remember that the slope is the number in front of the x, so 4/3, 8, -1, and 9. Pay attention here that, remember, the negative sign indicates a -1 in front of the x. And for the y-intercept, it's the number in the back, -9, 5, 2/5, and 0. There's nothing back there, so we write a 0. (16) and 17, I'm asking you to graph the line using the slope and the y-intercept. So remember, the y-intercept, you start at the y-intercept. Start here. So for both of these equations, it's -3 and +6. So I'm going to go ahead and graph both of those on the y-axis. -3, +6. Now I'm going to use my slope to help me get my next series of points. The slope for 16 is positive, so I'm going up 2 and over 1 from the y-intercept. So up 2 over 1, make a dot. Up 2 over 1, up 2 over 1. And you continue this pattern all the way across the graph. If you want to go in the other direction, you would go down 2 and then to the left 1. And you'll notice that this makes a straight line across the graph. This did have positive slope, and as I look at the line, I can see that I did go the correct way. That's always something that you should check at the end. You only had to have 5 points on the graph. I have a few more than 5, but I also like to go all the way through the graph. For number 17, you'll notice that the slope is already a fraction. It's 1 over 2, or 1/2, and it's also negative, which means we're going in the other direction. So if I want to go up 1, now I need to go to the left 2, up 1 over 2, up 1 over 2. Now I'm going to go the other direction because I need to extend my line this way through the graph. So it's down 1 over 2, down 1 over 2, and I can continue that pattern across the graph, and now I've run out of room. Remember that your lines, when you graph them, should always have arrows on each end. These are not segments, they're lines that would continue on in both directions. 18, 19, and 20 kind of take us back to those earlier sections before we started talking about slope, where you were finding what's called a rate of change. And rate of change is essentially slope. So to find the rate of change of this table, or this function in the table, we're going to subtract any two y's we want. So I'll do 1,000 minus 0. Notice the y's here on the bottom. But in the rate of change formula, they go up top. Then I'm going to subtract the x's, 2 minus 0, on the bottom. So that gives me 1,000 over 2, or 500 over 1. And when we write rate of change, we're always talking about some sort of unit. So it's 500, and it's the Y was on top, so it's miles per hour. You always want to make sure that you reduce your rate of change and that you have units. And then for the last two examples, this was when we talked about the constant K, or the constant of variation. So in order to find the constant of variation, you essentially are finding a unit rate here. So if we know that 4 reams cost $6.80, we need to find the price of 1 ream. So we take $6.80 and you divide it by 4, and you get that a ream of paper costs $1.70. So that's your K, or your constant of variation. So your equation, notice it asks you to write an equation. The equation that you're writing is one that someone could use to find the cost of any number of reams. So we're going to go back to this y equals kx, and we're going to plug in the $1.70 for K. So now if someone said, well, how much are 50 reams? How much does 10 reams cost? How much does 27 reams cost? Then you can just plug that in for x, 1.7 times that number. So then again, in example 20, we're asked for 12 reams, so it's y equals 1.70 times 12. 1.7 times 12 is $20.40. So it costs $20.40 for 12 reams. I know that a lot of you could probably solve this type of problem without writing the equation, but because it's specifically asked, we want to make sure we understand what this equation with the constant of variation looks like. So that's it for your sample test. If you want to take some more time to kind of go through this more slowly, if there was a certain type of problem you didn't understand, please feel free to go back and re-watch those parts before you take the assessment on Study Island. Once you've finished with the Study Island assessment, I do expect that it remains quiet in the classroom, so you can be working on missing assignments. I know the missing assignment report came out yesterday, or you can read quietly. You can work on other homework you may have, but please try not to be a disruption for others.